Hi, so today's lecture is about colorectal cancer and the colonic polyps. So, when I divide the polyps, and this lecture is not going to be much of written work because there's much of explanation that is required for this particular lecture. So, when I'm talking about polyps, polyps are divided two into a lot of different types. So first is a hyperplastic polyp, okay. Then there's an hematemus polyp. There's an inflammatory polyp, and then there's the adenomatous polyp. Now we all have heard about adenomatous polyp, correct? As seen as in the second year, we've heard about APC, adenomatous polyposis, and we've also heard about the inflammatory polyp, which is seen as a pseudo polyp in bowel inflammatory bowel disorder, something like an ulcerative colitis. But what is an hematemus and a hyperplastic polyp? An hyperplastic polyp is simply a polyp which is due to increased regeneration. Okay. But what about the hematemus polyp? Hematoma is just tissue that is random, that is not supposed to be on its actual position or its actual location. So, an hematemus polyp is basically a polyp which has a lot of mixed tissue. Okay, mixed tissue. All right. So let me just talk about the inflammatory polyp. Inflammatory polyp is seen in ulcerative colitis, as I said already. It's seen in ulcerative colitis. Is it a pre-malignant? Yeah, they are not pre-malignant, okay? So they are not pre-malignant. That's important because ulcerative colitis or an IBD can cause malignancy. But if someone asked you if the pseudo polyp is pre-malignant, no, definitely not. But is ulcerative colitis pre-malignant condition? Yes, it is a pre-malignant condition. Okay, so let's say you see a pseudo polyp, okay, for some reason, or you see a hyperplastic polyp, you cannot say it's a pre-malignant condition. It's not a pre-malignant condition unless there is a background of ulcerative colitis or Crohn's, and if it's a pseudo polyp, obviously it has to be ulcerative colitis. That point being covered, if it's ulcerative colitis, that means the rectal polyp is often involved, okay, when it's an inflammatory polyp. So in the pseudo polyp, the rectal valve is involved. Rectal wall. So the rectal wall is involved. There is bleeding. There is proctitis. As you all know about ulcerative colitis, there is pain and stuff like that. What about a hyperplastic polyp? I told you there's increase in turnover of the cell and there's increased goblet cells. So I'll just write simple: increased goblet plus epithelial cell. So because of that, you're just having a polyp that is seen. And it's usually seen in olders, it's like 70 years of age. So if you see a hyperplastic polyp in an old elderly person, okay, it's perfectly normal. Hematemus polyp, this is what I wanted to talk about since a long time because there are a lot of disorders that can be associated with hematemus polyp. So the hematemus polyp, let's talk about a few disorders that can be involved. If it's a single polyp, it's a single juvenile polyp, which is hematemus, there is no cancer. There's no cancer risk. Literally, I'm saying no cancer risk. There's another syndrome called juvenile polyposis syndrome, JPS. It's associated with SMAD4 mutation. Okay, SMAD4 mutation, juvenile polyposis syndrome. It's associated with multiple polyps, and associated with cancer. So juvenile polyposis syndrome is one important disorder that you should keep in mind. But apart from that, there is another very important syndrome. Okay, it's called Peutz-Jeghers syndrome. Now, what happens? It's a triad of pancreatic carcinoma. There's a very high risk of pancreatic carcinoma, almost 100% risk. So that's why I'm including it in the triad. There is obviously the polyps that's seen, multiple hematemus polyp, H for hematemus, and there is perioral melanosis, that is pigmentation around the lips. Okay. So that's Putzger syndrome, and it's polyp throughout the GI tract. Okay, and it's also associated with increased risk of breast, GI, um, stomach. Okay, any type of cancer. So there's an generalized increased risk of cancer. But one particular cancer that you should remember is pancreatic cancer. You can obviously get thyroid cancer as well, you can get breast cancer as well. But one particular cancer that we should remember is the pancreatic cancer, because pancreatic is POEDS. POEDS, P for pancreas, P for POEDS. Why does this occur? It occurs in 10 to 15-year-old, seen in 10 to 15 year, because by then only all the manifestations are seen. And it's because of the gene mutation STK-LKB. STK-LKB. I don't know if that's important, but JPS is due to SMAD, that's important, multiple polyps associated with cancer. A very important point that I wanted to make is that they are seen in less than 5 years. So juvenile polyposis is seen less than 5 years. And that's about it. And here, the multiple polyp in Puig-Heger syndrome has an arborizing pattern. Arborizing is a fern-like pattern. Arborizing pattern. So the polyp is something like this. Okay, if this is the mucosa of the large intestine. Okay. So this is going to be the polyp. It's literally like a fern. It's like a Christmas tree, arborizing pattern. Next is a very important syndrome called Cowden syndrome. So cow, I draw a cow always. Okay, a weird cow. Okay, and I draw the breast of the cow. That shows that there is a breast carcinoma. Okay. I also show that there is a thyroid swelling. Thyroid swell. Okay, and the cow has those black spots right on its skin. So let's just make it yellow or red. Okay, so that indicates your lipomas, because there's a lot of fat in the cow. And one is ganglioneuromas, which is seen as those black spots, ganglioneuromas. Okay, so that is when you talk about Cowden, and it's associated with P10 gene. This is a very important MCQ. This is asked a lot of times, that Cowden is associated with P10, JPS with SMAD, and Puig-Heger is by LKB1 gene. Okay, our next very important disorder that obviously we did forget about the GI, that I wanted to make a point. I'm writing this down because there are hematemus polyps also seen here. Hematemus polyps. Okay, which is not malignant, obviously. We've got another very important disease called Myers-Smith Benayan Riley disease. Doesn't even matter. Okay, you just need to remember Myers-Smith disease. That's the only thing that you should talk about. The other part is not important. That's too long a name. So what is Myers-Smith disease? Myers-Smith disease is macrocephaly, hypopit, macrocephaly. The drawing is, I make the drawing so that I can remember what the disease is like. What is the triad? Okay, so macrocephaly, hyperpit, okay, in Myers-Smith, and there's obviously I go down thinking that this is the spinal cord, and here is the throat. So here is your hypothyroidism, and that's something that you have to remember. And this is very important that I draw. This is your penis. So there is penile pigmentation. So this is a lateral view of a weird ass diagram, where there is a macrocephaly with an increased mass, the hypopituitarism, a small pituitary, hypothyroidism. Then this is obviously you going down, and your penile or the penis, which has penile pigmentation. A very important disease that I wanted to talk about later was Cronkhite-Canada syndrome. And again, this is something that's associated with Cronkhite-Canada. It's associated again with polyps, hematemus only, plus Kylo, Koilinochia, that is nail deformities, plus alopecia, that's hair loss. So that's all about hematemus polyps. Another, because we are just talking about hematemus polyps, I did not talk about these two very disorders. Again, they are genetic. Is one is Gardner syndrome, and the other is the Turkett. Now, in the Gardner, you have FAP, that's FAP gene mutation. Sorry, FAP disease, that's familial adenomatous polyposis. Okay. Plus, there is some osteoid deformities, but there's a dermoid cyst. Okay. Uh, there is retinal pigment epithelium hypertrophy. Retinal pigment epithelium hypertrophy. Okay. And you have the impacted teeth or supernumerary teeth, so the teeth deformities. And obviously, as I told you, osteoid or osteous deformities like the osteomas of skull or mandible. Now, Turkett is associated with, what have I written? Turkett. Turcot. T for Turkett, T for turban, T for turban, T for gliomas. Medulloblastomas. Medulloblastomas are seen in children, but in adults it's seen a glioma. Adult glioma. Alright. And apart from that, obviously you have FAP. Okay. So these are the genetic disorders that are associated with polyps. Now let's directly jump into the polyps that we have been waiting for. That is the adenomatous polyp. Correct? We've been waiting for these. So the adenomatous polyp is of three types based on histology: tubular, villus, mixed. Which is the worst? V for villus, V for villain. Based on its again, its anatomy is divided into sessile and pedunculated. Each of these. So it can be tubular sessile, tubular pedunculated. Villus sessile, villus pedunculated. What is the worst combination? Villus sessile, because sessile is worse than pedunculated. Okay. So villus polyp, which is sessile, is a very dangerous combination. Okay, so these two. Now what happens is, because of these polyps, what will happen? These polyps increase sodium bicarbonate excretion. So you will have bicarbonate loss. You will have sodium loss. Correct? Loss. So you will have hyponatremia and metabolic acidosis. Correct? And hyponatremia. And you will also have hypoalbuminemia, because your albumin is also being lost as there is a lot of sloughing that's occurring. Okay. So let's do a classification of the pedunculated only. Okay. So this level of classification, where we are seeing the extent of the disease, is only seen in pedunculated, because sessile is, what is the difference between pedunculated? Pedunculated, there is a stalk. This is a pedunculated polyp. Sessile polyp, there is no stalk. So you cannot say that what degree of involvement is present. But pedunculated, you can say what degree or what depth of involvement is present. So level 0, okay, the level 0 is non-invasive. Okay, so it's non-invasive, level 0, or it's probably on the epithelium. Level 1 is that it's invading through the muscularis mucosa. So let me draw a better diagram where I'm actually showing you all different layers as well. This is the stalk. The stalk on the upper surface has obviously the mucosa. Then you have the lamina propria. Okay. Then you have the muscularis innermost. All right. That's about it. So if it's only up to the mucosa, it's level 0. Level 1 is it's invading through the muscularis mucosa, but limited to the head of the polyp. That means it's up till here. Muscularis mucosa, not the muscularis proper. The muscularis proper is somewhere out here, obviously. The muscularis proper is somewhere out here. So it has invaded up to the muscularis mucosa, which is the yellow. So this is level 1. Level 2 is that it's going up to the neck of the polyp. Level 3 is that it's entered the stalk. And level 4 is that here we have the submucosa. Obviously this is the mucosa, the white. So here there's the submucosa. So it has invaded into the submucosa as well. So only the submucosa, not the muscularis proper. So this is the classification how you could have level 0, 1, 2, 3 and 4 for pedunculated polyps. If you see a pedunculated polyp, first thing you do an endoscopic resection. Okay. If it's a sessile polyp, you can infiltrate locally. What you do in a sessile polyp is because, see, so if it's a pedunculated polyp, you can just directly resect it. Okay, you resect it. But what if it's a sessile polyp? How do you resect a sessile polyp? You cannot get through with, you cannot damage the mucosa, correct? So what you do is that you first inject, and what happens is that the sessile polyp comes up because you inject some fluid or saline, and then you cut it from down. Okay, so this is called just infiltrate and resect. It's called infiltrate and resect method. So now let's talk about FAP syndrome, because we've spoken about the anatomy. Let me talk about the FAP syndrome. So FAP is a APC gene mutation, and what kind of a polyp is seen? Well, an adenomatous polyp is seen. An adenomatous can be of any type, correct? It does not really matter. It could be your villus, it could be your sessile, it could be villus, pedunculated, any. It doesn't matter. Okay, tubular. What matters in FAP is the entire sequence. So the mnemonic I use is AK53, AKS53. Okay. So AK53 is the A is for APC, K is for KRAS, S is for SMAD, and 53 is for P53.